Imagine the clearest, darkest night, and encountering some open place where the sky seems to wrap around you. You find a soft spot in the grass and lay down to stare up. Here, far from the crowds and the lights, the stars are dazzling. You can see the dusty bands of the Milky Way stretch through countless constellations of distant worlds. To gaze upon the night sky like this compels you to wonder, compels all of us to wonder, at the vast beauty of the universe and our place within it. This is part of what makes us human. We've surely wondered at the stars for over 100,000 years. But how you wonder, the stage of knowledge on which your imagination plays, turns out to be exquisitely unique in history. There have lived and died well over 4,000 generations of humanity, but only in the last dozen or so have we grasped a glimmer of the truth about the universe. You know that the points of light in the sky are actually infernos of hydrogen burning millions of light years away. You know that the stars and the sun appear to move across the sky because you're the one moving on a rotating planet. And you know that gravity orchestrates the entire cosmic dance according to universal physical laws. You even know the age of our universe. As you shift your position on the ground, you think of your own planet compared to the billions that must be out there. You know that here on Earth, storms are driven by pressure differentials, and earthquakes are caused by shifting tectonic plates. You know that life's diversity grows through evolution. But what else remains to be discovered? Who else could be out there among the stars, wondering about the same things? That's it right there, the most important thing of all. Why you gaze in wonder at the stars in the first place. You know that while there is vastly more yet to be known, we will keep etching away at the mystery through a powerful method of discovery called science. How are we so privileged to possess such a tool of wisdom as our ancestors would have thought reserved for the gods? How did we so outdistance notions of magic and monsters and witches and werewolves to develop physics and chemistry and a cosmology filled with other planets? How did we mature from belief to knowledge? I give you modern science and how it began. About 100 generations ago, a group of men had started making a relatively curious habit of sitting together in the shade of some olive trees to discuss nature in the same way they discussed politics, rationally. While most of their peers were pondering the logical benefits of a novel form of government they called democracy, these men were attempting to understand the universe through a comparably logical framework. One of them was named Plato, and over the entrance to the school he founded for the study was inscribed this motto: "Let no one enter who is ignorant of geometry." These ancient Greeks established the first known system of what can be called natural philosophy, the rational investigation of natural phenomena and their causes. Rational because the ideas they proposed about how the world worked were disciplined by math rather than myth, and by observation rather than superstition. More than the indulgent speculation of the idle rich, these Greeks sought knowledge of nature as a means to do what all people have strived to do since the beginning: predict natural events and thereby gain some control over their fate. Through observational and geometrical analysis, Plato's cohort reasoned that the Earth was a sphere, and they succeeded in developing an astronomy that predicted the motions of the stars with a level of accuracy that would not be surpassed for 2,000 years, although their model placed the Earth at the center of the universe, with all the celestial bodies revolving around it. A student of Plato's, who later became tutor to Alexander the Great, was named Aristotle, and he expanded upon Plato's natural philosophy. Aristotle reasoned that 4 elements made up everything: earth, water, air, and fire, and he theorized that the natural properties of these elements, alone or in combination, accounted for all the world's behavior. Earth and water sought the center of the universe, for example, and so formed the world there, while air and fire sought the higher realms, and so made up the sky. The Earth certainly did not seem to rotate or move at all, and to demonstrate this experimentally, Aristotle suggested shooting an arrow straight up into the air and observing that it landed in about the same place. If the Earth were rotating under that sailing arrow, it should land some distance away. Beyond the earthly realm, Aristotle proposed the existence of something unique, a 5th element, unlike the other 4, called the quintessence, or ether. This realm, Aristotle reasoned, was incorruptible and absolutely unchanging. It appeared to move around the Earth in a perfect, unending circle. 1,000 years later, the Christians of Europe called it heaven. Of course, the ancient Greeks got most of their conclusions about how the natural world works wrong. Aristotle's thought experiment involving the arrow, for example, didn't take relative motion into account. And yet, while their conclusions may have been wrong, it was the method that they pioneered for understanding the natural world that held so much promise. Aristotle's focus was never to instruct his pupils to just believe certain ideas. He sought to teach a rational method for learning things about the world. With new information and new experience would come new insight, new knowledge. He likely assumed that his ideas would be replaced by better ones in the future. But in fact, during the centuries after Aristotle died, amid the turbulence of shifting empires and the aggressive expansions of Christianity and Islam, the Greek tradition of rational inquiry eroded, and its institutions crumbled. Its greatest edifice, the Library of Alexandria in Egypt, which had housed up to 500,000 papyrus scrolls covering subjects ranging from astronomy to anatomy, was completely destroyed by the 300s AD. Aside from a handful of cosmopolitan communities in places like modern-day Baghdad, Iraq, and Istanbul, Turkey, where relatively enlightened rulers persisted in protecting the methods of rational inquiry, natural philosophy all but came to a halt in Western civilization. And where they were remembered, the pieces of Aristotle's world model were merely encrusted into the belief systems imposed by religious authority. The Earth remained at the center, but now it was the center of the Abrahamic God's universe, where man dwelled in his image. Heaven revolved around us as a constant demonstration of his divine perfection. To publicly question this cosmic assumption was to challenge the Church, and so to court death. For 1,000 years between the 500s and the 1500s, the intellectual culture of Europe was rooted in religion. Scholarship itself was an almost exclusively religious institution, and within its ranks, monks were charged with interpreting Aristotle through the lens of religious doctrine. Ironically, they began to call themselves Aristotelians. But as the generations rolled by, Christian authorities increasingly struggled to preserve their monopoly on information and belief. The development of the printing press in modern-day Germany in the 1440s, along with the exploration of America by Christopher Columbus in the 1490s, initiated a two-front assault on the established worldview. On one hand, the printing press enabled information to spread farther and faster than church authorities could censor. When it was invented in the 1400s, the number of manuscripts published in Europe each year was around 50,000. By the 1600s, that number had risen to around 5 million. At the same time, people had an exceptional event to discuss: the discovery of an entirely new world about which the Church, just like everyone else, had been totally ignorant. If the Church had known nothing of nearly half the world, how could it proclaim exclusive authority over the destiny of all people? Dissenters multiplied. In 1517, a German monk named Martin Luther initiated the Protestant Reformation, formalizing attacks on the Catholic Church that would culminate in a 30-year bloodbath in the early 1600s, the most destructive war in Europe's entire history, prior to the world wars of the 20th century. With the chaos fueling widespread skepticism toward traditional beliefs, the European mind was wrenched open after 1,000 years of being tightly closed. Right in the thick of this unprecedented existential crisis, there appeared in the sky a new star. The year was 1572, and a Danish nobleman with exceptional vision and obsessive pattern recognition named Tycho Brahe noticed it first. We now know that what Brahe saw was a distant supernova, which became nearly impossible to overlook during the course of the next year, as it briefly brightened enough to be visible even during the day, before finally disappearing altogether in 1573. But for over a year, there for all to see, the new star represented a phenomenon that Aristotelians believed could not exist, for the heavens were supposed to be perfect and absolutely unchanging. It would have been like someone today seeing a stone fall up out of their hand, defying the laws of physics as we've known them for centuries. Of course, the printing press ensured that Brahe's conclusions about the nova, that its appearance contradicted Aristotelianism, were disseminated throughout Europe, emboldening others to corroborate and investigate further. Still, it remained a dangerous time in Europe to push too hard against the supports of traditional belief, especially for those living close to the Church's power center in Italy. Among this brave new generation of European natural philosophers, there were casualties. An Italian named Giordano Bruno was burned alive in 1600 by the Catholic Inquisition for concluding that the Earth revolved around the sun. A sun-centered model of the universe had, after all, been around for years, but almost no one took it seriously until after the nova of 1572. A Polish mathematician named Nicholas Copernicus had published an argument for it in 1543, the first person in the Christian era ever to propose such a theory. But his work was interpreted merely as a mathematical tool to make better sense of the annual motions of the stars and planets. After the supernova of 1572, however, suddenly the traditional model of the universe seemed far-fetched. Once investigators were finally willing to entertain the notion of a sun-centered universe, the mathematical and observational data became convincing. Over the next 30 years, converts to the Copernican model increased exponentially. Each new discovery and each new instrument of investigation compounded their conviction, emboldening European natural philosophers to more explicitly challenge traditional belief. Their collaboration was suffused with an utterly intoxicating sense of progress. The word "new" had never been so popular in the titles of their manuscripts. One instrument in particular would help deal a mortal blow to Christianity's Aristotelian dogma: the telescope. Invented accidentally in the Netherlands around 1608 through a fortuitous misalignment of spectacles, the telescope nonetheless presented immediately obvious applications in warfare and at sea, so it spread quickly across Europe. What was not so obvious, on the other hand, was to aim the telescope up, toward the night sky. But that's exactly what an Italian astronomer named Galileo Galilei did in 1609, becoming the first human being in history to gaze at the cosmos with more power than the naked eye. Made Galileo's creative impulse extraordinary in and of itself, but in so doing, he also almost single-handedly ensured a full-blown scientific revolution. The things that Galileo saw through his telescope helped to shatter the remaining remnants of the traditional worldview. He saw jagged mountains on the moon in direct contradiction to Aristotelian's claim of its heavenly perfection. He saw moons orbiting the planet Jupiter in direct contradiction to Aristotelian's claim that all celestial bodies revolved around the Earth. And as the final straw for many of his peers, Galileo clearly saw the phases of Venus, whose distinct patterns could only be explained by a sun-centered orbit. With this last piece of evidence, it was no longer professionally viable among natural philosophers to maintain belief in the Church's Aristotelianism. Within only a few generations, a tidal wave of investigators throughout Europe were inspired by Galileo to shed the old beliefs and explore the world anew. French philosopher René Descartes captured the spirit of the age best when, in his effort to throw out all traditional ideas and proceed from absolute philosophical bedrock, he uttered, "I think, therefore I am." New discoveries piled up in short order. German astronomer Johannes Kepler buried the old obsession with perfect celestial circles by revealing through mathematical analysis that planetary orbits were actually elliptical. Dutch craftsman Antony van Leeuwenhoek invented the first microscope to observe an entirely new world of microbiology in a single drop of water. Italian experimenter Evangelista Torricelli built the first barometer to prove that a vacuum, or the absence of air, could exist, contradicting a 2,000-year-old belief that it couldn't. French mathematician Blaise Pascal used Torricelli's barometer to demonstrate changes in atmospheric pressure according to altitude. English philosophers Robert Boyle and Robert Hooke built a new device called an air pump that enabled Boyle to simulate a vacuum for controlled experiments and thereby decipher the effects of air on respiration, combustion, and sound. All of these men lived in different countries, spoke different languages, had different personal motivations, and even often came to different conclusions regarding many of their investigations. But what they shared, what they were creating together, transcended all that and converged on the same goal. It was a culture of experimental science. The experiments with barometers and air pumps in particular helped convey the essence of the scientific revolution. Since the beginning of the Christian era, people were taught to believe that a vacuum, or the absence of air, could not exist, explaining a phenomenon like the force of suction, for example, in terms of God or nature refusing to let a vacuum occur. These kinds of explanations of natural events, such as they were undertaken to justify what was already assumed to be true, not to interpret new observations or facts that came to light. Experimenting with how to create a vacuum in an air pump or a barometer, therefore, would not have made any sense to Christian Aristotelians. It would have been akin to experimenting with why 1 + 1 = 2. They believed it was self-evident that God simply did not want a vacuum to exist. So when Blaise Pascal became the first person to take a barometer to the top of a mountain, where he observed the mercury in its column descend, opening up a widening vacuum above it inside the barometer, Aristotelians judged the experiment to be meaningless, for there was no reason in their belief system for nature to abhor a vacuum any less at altitude, just like there'd be no conditions to alter the fact that 1 + 1 = 2. At best, Aristotelians could only refuse to believe that a true vacuum had been achieved between the column of mercury and the top of Pascal's barometer. But a vacuum, indeed there was, and where Aristotelians saw a meaningless trick, Pascal and his cohort of natural philosophers saw new experimental evidence, in this case that the air composing the atmosphere had a weight to it that exerted pressure that would diminish as he rose in altitude. Pressure that went only so far before allowing for the formation of a vacuum after all. From Pascal's barometer to Boyle's air pump, accumulating experimental evidence with the effects of air pressure helped investigators to refine their predictions into theories of how vacuums and gases worked at a fundamental level. The methodology of rational inquiry had emerged once again as the most important feature of knowledge. To inoculate the modern mind against 2,000 years of indoctrinated belief, the leaders of the movement focused as much on the question of how to establish legitimate scientific knowledge as on the production of knowledge itself. And over the doors to their school, they would inscribe this motto: "Take nobody's word for it." The credo was a corrective to the oppression of all forms of dogmatic authority, whether it came from religion or not, and it defined the difference between belief and knowledge. Many of these men were themselves devoutly religious and studied nature as a means to better understand God. For them, the key difference was that real knowledge about the world did not come merely from a single book or church leader, but that it grew out of the systematic experimental and mathematical study of nature, and that humanity possessed the power to invent new tools of discovery. Only through this could the true spirit of Aristotle be restored. They were well aware that so little was known compared to how much remained to be discovered, but despite the inevitable errors in judgment to come, the methods of the new science were to be a built-in corrective that would steer us ever closer to truth. In 1687, the English physicist Isaac Newton published what can rightly be considered the culminating work of the scientific revolution, titled The Mathematical Principles of Natural Philosophy. Therein, he not only distilled a century worth of work into the universal laws of motion and gravitation, but he enshrined the philosophical values that had inspired that work all along. After a century of heroic effort to renew humanity's power of reason, modern science had officially begun. What is the nature of the universe and our place within it? How does the world work, and how can we predict its behavior to better control our fate? As much as any physical attributes may have defined the first humans, it was the first minds to ponder these questions some hundreds of thousands of years ago that inaugurated the human experience. Through the ages, there have been as many approaches to answering those questions as there have been cultures. And for long periods of time, sometimes thousands of years, certain of those approaches dominated for the sake of established order at the expense of truth. However relative some cultural values may be, there are right and wrong answers to how the natural world works. Out of the vast reservoir of history, the ancient Greeks appear to have been the first to establish a rational investigation of those answers. Eventually subsumed beneath the weight of other cultural imperatives for 2,000 years, their foundational spirit of rational inquiry was fully excavated by Europeans during the scientific revolution of the 1600s. The dramatic increase in our ability to predict natural events in the few short centuries since is a testament to the power of modern science to decipher truths about the world in a way that no other system of knowledge has ever been able to do. Ironically, the knowledge-making machine of modern science those revolutionaries set in motion has proven so productive that it has become appropriate once again to defer to authorities regarding the world's behavior, or risk being inundated by the oceans of information we've discovered. Before your next visit to a comfortable patch of grass under a brilliant night sky, check with an astronomer about upcoming meteor showers. She'll know exactly when they'll be.